Welcome, ladies and gentlemen. We're going to start a new unit, and this unit starts off with representing proportional relationships. So make sure you have your Slammin' Salmon colored foldable, and let's look at the written description tab. It says, when given a written description of a proportional relationship, you can find the unit rate to determine the constant of proportionality. The order you use to set up the ratio needs to be the same for both parts of the proportion. Now, when they say that the ratios need to be the same or set up the same, that means that you'll see how they have words on the top on the first ratio. Therefore, words has to be on the top in the second ratio. And then, of course, at the bottom we have minutes, and minutes have to match up with minutes on the bottom of the second ratio. If we were going to solve this ratio right here, you could cross multiply and divide, but there's also an easier way to do this particular one. 50 times what would give us 150? Well, 50 times 3. Whatever we do to the top, we have to do to the bottom. So 2 times 3 would give us 6. Therefore, the answer to this would be 6 minutes. Okay? Alright, let's look at the next part of the written description. The next example says, if you can buy one bunch of purple grapes for $2, how many bunches of grapes can you buy for $18? Well, we've got to think about what are the two things that we're talking about. We're talking about bunches of grapes, and we're talking about the cost. So over on the other side, we must also have bunches and cost. So we set up our proportion. We can buy one bunch of purple grapes for $2. They want to know how many bunches of grapes can we buy for $18. And again, you could cross multiply and divide, or you can say 2 times what is 18? 2 times 9. So then we take the top times 9. 1 times 9 gives us 9. So therefore the answer is 9 bunches. Okay, let's go to our Tables tab. It says a table gives pairs of values. You need to determine whether they form a proportional relationship with a constant ratio. In other words, the same ratio. And write an equation. So if you look at the first table, it has A, 1, 2, 3, and then your B values are 6, 12, and 18. Another way to look at this is your X, and this is your Y. When we're looking at our constant of proportionality, we always do our Y over X. So if we did 6 over 1, that's going to give us what? Well, 6 divided by 1 is 6. Okay? If we do 12 over 2, 12 divided by 2 is 6. If we do 18 divided by 3, that gives us 6. So therefore, this is proportional because we had the same ratio for each pair of values. Okay, now we've got to write an equation. Well, since we know that our constant of proportionality, the COP, is 6, then we write an equation in the form of y equals k times x. K is our constant of proportionality. So y equals 6x. This would be our equation because we are taking 6 and multiplying it by 1. Okay, and then we'll take 6 and multiply it by 2, and that gives us our 12. And then we'll take 6 and multiply it by 3, and that gives us our 18. Okay, let's look at the next table. They want us to determine whether or not it's a proportional relationship. So again, remember that we do y over x. So we do 6 over 2. 6 divided by 2 gives us 3. Then we need to do 7 over 3. If you take 7 and you divide it by 3 on your calculator, you're going to get 2.3 repeating. And then we have 8 over 4. 8 divided by 4 is 2. So, is this a proportional relationship? No, it is not, because each ratio or constant of proportionality was different. Okay? Now, as I'm looking here, I realize that I did not put the correct table in for writing the equation. The table that should have been here looks like this. We have 12 and 4, then we have 9 and 3, and then we have 6 and 2. Remember that this is the same thing as our x, and this is the same thing as our y. So remember that we do y over x, so we're going to say 4 over 12. 4 over 12 will reduce to 1/3. Here we do 3 over 9, which will reduce to 1/3. Then we do 2 over 6, which will reduce to 1/3. Therefore, our constant of proportionality is 1/3. So if we're going to write our equation, remember we do it in the form of y equals k times x. And k represents our constant of proportionality. So we would have y equals 1/3 x. Okay, we are going to skip over the Diagrams tab and we're going to go to Graphs. It says an equation for a proportional relationship can be represented by a line on the coordinate plane. The line passes through the origin. So, in other words, in order for it to be proportional, the line has to pass through the origin. Okay, then it says the ratio of the y-coordinate to the x-coordinate for every other point on the graph is equal to the constant of proportionality. That means you have to have a constant ratio like we just talked about. Every time you take values in a table, they need to be able to come up with the same ratio. So our first example gives us a table of values. They've given us some x values. Then in the next column, they want us to take 2 times the x value. So in other words, in this first one, we are saying 2 times 0. Well, that's going to give us 0. Then they want to take 2 times 1, which would give us 2. Then we say 2 times 2, which would give us 4. Next we have 2 times 3, which gives us 6. And last we would have 2 times 4, which gives us 8. So now, next we have to graph those. Well, let's look at our ordered pairs. We have 0, 0. We have 1, 2. You notice I'm taking the x and the matching y. Then we have 2, 4. Then we have 3, 6. And last we have 4, 8. So on the coordinate plane, I'm going to plot 0, 0. Then I'm going to plot 1, 2. Then we have 2, 4. Next we have 3, 6. And then last we have 4, 8. Okay, so we have to ask ourselves, is this proportional? Well, we see that it does what? It passes through the origin, correct? So, it passes through the origin. The next thing we have to do is determine whether or not we have an equal ratio. So remember, we take our y over our x. So we have 2 over 1, which would give us 2. Then we have 4 over 2, which would give us 2. And then we have 6 over 3, which would give us 2. And then we have 8 over 4, which gives us 2. So it passes through the origin, and it has a constant of proportionality, which is equal to 2. If we were going to write the equation for this, we would say that y is equal to 2x. So since we have that it passes through the origin, it has a constant of proportionality, and the equation is in the form of y equals kx, therefore this is proportional. Okay, so we just learned that in order for a graph to be proportional, it has to pass through what? It has to pass through the origin. So when we look at this graph, does it pass through the origin? No, it does not. Therefore, it is not proportional. And the reason is that it does not pass through the origin. And that's all for proportional relationships. Y'all have a good evening, and I'll see you tomorrow.